How old is the universe? It is troublesome to envision that only a few decades ago, we did not have familiarity with the existence of a large portion of the universe around us. As a matter of fact, most stargazers believed that the Milky Way contained all the stars in the universe. In 1917, Heber Curtis saw a nova, an unexpected eruption of brightness resembling a new star, inside what was then referred to as the Andromeda Cloud. Novas typically emerged quickly and then gradually dimmed over weeks or months. This captivated Curtis, and he began searching for additional novas in visual records. He found 11 more of them. However, what truly piqued his curiosity was that the novas in Andromeda were significantly fainter than those in the Milky Way. Based on this observation, Curtis was able to estimate that Andromeda was 500,000 light-years away. Therefore, he became an advocate of the so-called island universes theory, which held that objects previously believed to be spiral nebulae within the Milky Way were, in reality, independent galaxies. This was a revolutionary step for humanity and cosmology. Yet we still assumed that the universe was static. Albert Einstein even added something called a cosmological constant to his equations to ensure the universe remained still. Fast forward to 1928. Edwin Hubble's measurements of galaxies led him to the realization that the universe was continuously expanding. This observation suggested that the universe had a finite age and that this age could be estimated by mathematically tracing back in time. With this, Edwin Hubble first estimated the universe to be just 2 billion years old, a value that we now know is far from the universe's actual age. The discovery of the cosmic microwave background radiation, announced in 1965, finally put an end to any lingering scientific uncertainty about the expanding universe. While we were now certain that the universe was expanding, its actual expansion rate remained a mystery. Over the following decades, uncertainties surrounding the true expansion rate ignited a fierce debate, with estimates ranging from 8 billion to 18 billion years. The discrepancy in calculations became even more pronounced when scientists began to determine the ages of the oldest main sequence stars and found that they were more than 8 billion years old. Clearly, there could not be stars older than the universe itself, and this created a major impasse in cosmology. Enter the Hubble Space Telescope. In 1997, its observations triumphantly resolved the debate by revealing that the universe was not expanding at a constant rate, but rather accelerating due to an unknown repulsive force named dark energy. When dark energy was factored into the universe's expansion history, astronomers arrived at an age estimate of 13.8 billion years. However, a problem remains. A parameter used in cosmology to describe the rate at which the universe is expanding, called the Hubble constant, is still up for debate. Based on fundamental physics and cosmic microwave background radiation, scientists believe the Hubble constant should be around 68 km per second per megaparsec. However, this does not match the observations of real stars and galaxies in our immediate cosmic neighborhood. This raises a crucial question. What if everything we thought we knew about our universe's age is only a partial truth? Brace yourselves, because here is a shocking discovery. A group of stars in the Milky Way appears to be as old as the universe, or perhaps even older. Star cluster M92, a densely packed group of stars about 27,000 light-years from Earth, is estimated to be around 13.8 billion years old. The newly refined age estimate makes this cluster as old as the universe itself. This could challenge the current age of the universe and set a new boundary for it, thus resolving cosmic dilemmas about how the universe evolved. The age is on the edge as estimated by different groups, said astronomer Martin Ing of Dartmouth College. It helps us set the lower bound of the age of the universe. We don't expect the star cluster to be older than the universe, right? Globular clusters like M92 consist of densely packed gatherings of stars believed to have formed simultaneously, simplifying the task of determining their ages. Stars follow different life paths depending on their mass. At birth, larger stars burn through their fuel quickly and have shorter lifespans, while smaller stars last much longer. Understanding how many stars in a cluster have moved past their primary fuel-burning stage provides insight into when the entire cluster began forming. However, age estimates traditionally rely on assumptions about stellar evolution. Seeking a more reliable method, Yang and his colleagues used a computer to generate 20,000 synthetic stellar populations for M92, each representing a potential cluster age. They then compared the colors and brightness of each population with observations from the Hubble Space Telescope to determine the best-fitting age estimate. While M92's age had been measured before, previous estimates relied on a single synthetic star population. By comparing thousands of synthetic populations, the researchers significantly reduced the uncertainty associated with the assumptions in each model. This innovative approach resulted in a 50% reduction in the uncertainty of the cluster's age. They determined that M92 is around 13.8 billion years old, with a margin of error of about 750 million years. Surprisingly, this age closely aligns with the best estimate for the age of the universe, just over 13.8 billion years, with an error margin of around 24 million years. One way to resolve this tension is to reconsider the universe's estimated age. If we take the Hubble constant discrepancy seriously, we may have to admit that we do not know the universe's age as well as we thought. This discovery reignites discussions surrounding a recently published study from the University of Ottawa, which suggests that the universe is not 13.8 billion years old but rather 26.7 billion years old. To summarize, the new model emphasizes the existence of stars like Methuselah, which seem older than the universe's estimated age, as well as the discovery of early galaxies with the James Webb Space Telescope. These early galaxies, observed just a few hundred million years after the Big Bang, exhibit levels of maturity and mass typically associated with billions of years of cosmic evolution, presenting a major puzzle. Advancements in computing theoretical understanding, precise measurements of cluster distances, like M92, and the discovery of primordial galaxies in the cosmic dark age may hold the key to solving these mysteries. What do you think? Is the universe older than 13.8 billion years? Do we need a new approach? Renowned physicist Michio Kaku had, in fact, predicted this a year ago, suggesting that the age of the universe might need to be revised. If it turns out that the universe is older than we think, well, that's a big problem, Kaku remarked. The James Webb Space Telescope is shaking up the field. Suddenly, we realize that we might have to rewrite all the textbooks about the beginning of the universe. Takes billions of years to form a galaxy like the Milky Way, which has over 100 billion stars. However, the James Webb Telescope has identified 6 galaxies that existed only a few hundred million years after the Big Bang, yet they are up to 5 times larger than the Milky Way. That shouldn't happen. There shouldn't be primordial galaxies bigger than the Milky Way that are only 500 million years old. Something is wrong. We may need to revise our theory of the creation of the universe.